So I would say let's start. So welcome to our Waldner Labcafé online. And thanks a lot that so many people are interested in this sustainable topic. My name is Alexander Biller, and I'm looking forward to share a lot of inspiration with you. Our topic today, green lab projects, best practice around the world. Laboratory buildings consume 5 up to 10 times more energy as office buildings. Therefore, it is so important to question and rethink all aspects, from the location to materials, energy and safety concepts, process and operating procedures, supply and disposal, and much more. Together, we will look at best practice examples from all around the world and learn firsthand out how this has been solved. And we have a fantastic speaker today. Impulse number 1 is about what are the possibilities to create a green science building. With Steffen Vogt, he's managing director at Wolf Architects, so he has the planner perspective. He studied architecture at the Stuttgart University of Applied Science and the Technical University of Delft in the Netherlands. Afterwards, semester abroad at the École d'Architecture de Paysage in Bordeaux, in France. So he's educated very internationally. Since 1999, he has been working for Wolf Architects. Since 2009, he has been a leading architect. And since 2015, he has been the managing director. So it's a pleasure to have you on board, Steffen. And impulse number 2 is about why did we rethink our science engineering complex, the SEC, in a completely new way with Quentin Gilly, Assistant Director, Sustainability and Energy Management at Harvard University. At Harvard, Quentin supports the Faculty of Arts and Sciences in achieving their climate and sustainability goals, primarily through implementing decarbonization projects and healthier building standards. So Quentin, I'm very happy that you're on board from the US. Thanks a lot. Looking for your impulse. And impulse number 3 is focusing on the question, how could we implement sustainable aspects into lab facilities? With Alexander Bischel, Head of CAPEX Management Germany from Boehringer Ingelheim. And the background of Alexander is electrical engineer. He has over 25 years of engineering and project management experience. Today, he's responsible for the big projects in Biberach and Ingelheim. And I know he's a good sportsman, triathlon, I know that. And I'm very happy that you're on board, Alexander. Looking forward to your impulse. And at the end, we have a Q&A session. And so if you have questions, please write it in the chat so that we can answer them. And then I would say, let's take a good cup of coffee, be inspired, and I directly hand over to you, Steffen. It's up to you.
So good afternoon, everyone. I hope you are all enjoying your cup of coffee. What are the possibilities to create a green science building? I don't know if I can give general answers to this question. Therefore, I'm going to give you an insight into our work. I start with a short overview. The alignment of footprints show a various range of projects with different structures and size, going from small tasks to huge infrastructure projects. All the buildings in pink are our laboratory buildings. Sustainability is a maximum that guides us from the beginning of the office. Within the finalization of the Fair Trade Center in Stuttgart 2007, it's the biggest one here, we already realized a radical reduction of the processed air volume in a public building by only supplying the visitors area with fresh air, a topic which is in discussion in every science campus in the world in the moment. These are the certification systems we are working on in the moment. Mostly, we work with the German federal system, this one, to evaluate sustainable lab buildings. But we are very proud that last year we finished our first cradle-to-cradle project, the fire station in Straubenhardt near Karlsruhe, but that would be another lecture. This was our first experience in cycle economy, a new task which will also influence the construction of lab buildings in the future. In the last 20 years, the terms we were talking about changed several times. We started with energy efficiency, then some years we had green buildings, then started the word sustainability. Nowadays, we're only talking about climate neutrality. Priorities changed, starting from natural ventilation in the beginning, solar gains, energy efficiency, ecological materials, then gray energy, the moment cycle economy, and finally, carbon neutrality. The concepts and many technical solutions are much older than the political and social pressure to implement them into the goals of the projects. Regardless of that, the image of the 5 pillars of sustainability tries to integrate all these ideas within one structure, which helps to weight the single solutions and decisions, even if the hurdles are way too low to reach a full carbon neutrality with these systems. Now I'm talking about the federal system to evaluate sustainable science buildings. This is the visualization of the federal system. The size of the boxes represents the percentage of the topic. As you can see, the 6 biggest topics are ecological balance and primary energy demand, life cycle costs, adaptability, risks for local environment, area efficiency, it's on 5, and the quality of the building technology. An overview about our sustainable science buildings. All of them will be certified by the federal system, nearly all of them, the system I explained to you before. It's good to know that the highest grade in the system is gold and not platinum, as in a lot of other systems like DGNB or LEED. Starts with the DZNE, the German Center for Neurodegenerative Diseases in Bonn, a member of Helmholtz. It's the headquarters of one of the federal health centers of the 5 most common diseases. A complete institute campus starting with administration, cafeteria, lecture hall, over basic research laboratories, an animal facility, to a clinical research department, from bench to bedside. It's about 130 million and 36,000 area of total area. The first lab building in Germany, which reached gold level in 2017. The next one is the HPC, the science building for Helmholtz Munich, also part of the federal health centers. A medical research building designed for interdisciplinary work. The building will be finished this year and will reach silver. Then a science building for the research center in Jülich, also member of Helmholtz, a research building for the Institute of Energy and Climate, designed for industrial electrochemistry, means batteries. The building is our first science building with a wood-concrete hybrid construction. It will be finished this year also and also will reach silver. And then the ELH, a science and college building for the University of Berlin. The topic is meat and food safety. The building has only 1 level of usable area because of urban and landscape reasons. It's a huge photovoltaic roof, and it's our first science building with a total coverage of the energy consumption by air, water, heat pumps with support of photovoltaics. It will be finished in 2025 and is supposed to reach gold. The next college building for the University of Reutlingen. The topic is chemistry. It's characterized by a flexible floor plan concept, by a total coverage of air, water, heat pumps, and a photovoltaic facade. It will be finished in 2027 and it will reach gold level. It's supposed to be. The other ones I skip. Because every project would have the potential for a single lecture, I'm going to point out 6 in the following. I will highlight special features to show the difference in the development of the priorities over time. We start with the DZNE. Facts and figures I already explained to you. To remember, it's the first research building in Germany which reached gold level. That's why we focus on the sustainable objectives of the design. No worries, I'm not going to explain all of them. I point out some of them, which I explain in the following. The task is complex. The solution has to be simple. The design is characterized by a large building depth with a very flexible open space lab concept. This design has to find creative answers to such a large building depth. The section is characterized by 4 rows of lab spaces getting more height and ease the closer they are to the facade. Indirect lighting, silver covering of the ceiling in combination with a carefully developed documentation zone are these answers. The HPC I already explained already. The overall sustainable objectives are nearly the same. The genius loci is different. Also, the circumstances of the campus in Munich. The energy concept is based on the infrastructure of the campus, which is the use of well water for cooling. The major skills of the design are dynamic reduction of the air change rates in the labs, also a topic which is in discussion everywhere in the world in the moment, and highly differentiated communication spaces. As you can see, the first sketch of the design concept, the border between lab and office spaces is nearly invisible. Offices and labs are in the same fire cut, as you can also see in the perspective. The corresponding building technology, which has to be that flexible too. The material concept is rough and reduced. Common areas are highlighted by warm materials like wood. The rest is rough concrete and visible technical infrastructure. The project in Jülich. The main challenge of the project in Jülich is the construction method based on wood-concrete hybrid construction. Because of the bad performance of the campus infrastructure, in difference to Munich, where we had the well water, the bad performance in regard to primary energy demand, we had to find a possibility to use the primary energy demand to reach silver level, even because it's the Institute for Energy and Climate. So this is the main topic I would focus on. A photo of the nearly finished building within the forest, which was also one of the ideas to catalyze the wood idea, and a perspective of the main entrance. The design is characterized by a huge 2-level lab unit with 1,000 square meters with a central airspace for NMR devices, with corresponding lab, office, and workshop spaces in only one fire cup. Remember, we have to build in wood. So the first sketches, and here's some drawings of the building and the final section. And some impressions of the construction period, which are dominated by the warm character of the wood construction, which looks like this in the end without covering of the surfaces. Now the project in Reutlingen, a college building for chemistry. Among the topics of the main challenge of the project in Reutlingen is the construction method of the facade. A solar shield is activated by gray photovoltaic panels. The geometry is designed to eliminate completely movable sun protection. Through this, the surface area for photovoltaics, which run the air-water heat pumps, is maximized, roof and facade. That's how it looks like. And last but not least, the ELH, college building for the University of Berlin. The building has only one level of usable area because of urban and landscape reasons, as you can see in the picture. It has a huge photovoltaic roof. Also, the skyline is a picture to the agricultural situation around. It has a huge photovoltaic roof, and the total coverage of the energy consumption by air-water heat pumps with support of photovoltaic. Nowadays, everybody is discussing about heat pumps, but 3 years ago, when we won the competition, running a laboratory building with only heat pumps was very experimental. You see the site plan, you can see the situation within an agricultural institute and the border to the open landscape. The roof landscape with the integrated centralized spaces for the building technology, it's this. So it's technical infrastructure for every lab, so we don't need fire protection system between technical infrastructure and lab, and the floor plan, which is very dense, and the section. Yeah, this is the technical infrastructure for the labs. Short summary: by focusing on the outcutted projects, I try to show you our approach to create green science buildings, which is visible throughout all the projects. I hope so. Nevertheless, every project has special challenges which depend on the given circumstances. My hope for the future is that we'll have a great variety of experience which can be combined for the development of future solutions. That gives us a chance to face the even more challenging future that is ahead of us. Thank you.
So many thanks for showing the different possibilities to realize sustainable buildings. Steffen, perhaps you can stop sharing your presentation, and then I would have a direct question to you, Steffen. If I want to build a very sustainable science building, what would be the 3 biggest points for you to think about? So you showed many aspects: construction with wood, photovoltaic, and pumps, and so on. What 3 aspects do you want to show or start with?
We start with the concept. What I think is common with all the projects I show is a very deep floor plan, which has a very strong structure. First, you think all the labs look the same, or they actually are the same. But in the end, we found out after several projects that if you have found the right structure, you're completely flexible to integrate all the needs of the scientists, and these structures are the basis to create flexible technical systems for the building, and also to reduce the surface of the facade. So this is the first thing, just to reduce the impact and to design a building which is that flexible that you can face all future needs without changing things. Mm-hmm. After that, you have to analyze the circumstances. Do you have technical infrastructure or not? Do you have well water, or you have to create a single thing? For example, the Berlin project, we had the competition with 1 level because of urban situation things. And then we said, okay, 1 level is actually a strange answer to a science building, but then we have to create a huge photovoltaic roof, and we have to use this for running heat pumps. So the impact to use heat pumps came from the architecture, not from the engineers in the end.
Okay, great. So thanks a lot for your impulse and a great overview to different projects. And then I would say I hand over directly to the US. To you, Quentin.
Thank you. Thanks for having me today. Awesome. All right. So today I'm going to tell you about our science and engineering complex at Harvard University. It is essentially was designed to be one of the healthiest, most energy efficient laboratory buildings in the world. And also the same goes with climate resilience. Finished right around 2021 in a 6-story facility designed by the Boston office of Banish Architect, which is a renowned architecture firm known for designing sustainable, innovative research buildings. It's a 544,000 square foot building, and it includes 70,000 square feet of public green space. And it is essentially meant to be Harvard's statement for the 21st century. You know, this is the building we need to be looking towards as we build more buildings and we retrofit our existing buildings on campus towards a fossil fuel free future. So just a little bit of background. So at Harvard University, when we talk about sustainability, we're talking about climate, health, and equity. We also have a climate action plan, which is focused around our goal in 2026, which is to be fossil fuel neutral. And that's after we've already reduced the campus by over 30% in emissions as of 2016. And our longer term goal is to become completely fossil fuel free. And there's some interesting components to this project that connect with that fossil fuel free future. Because and essentially some of those things essentially mean that we're still learning on how we're gonna get there. So, but we're already thinking about it as we move forward. At Harvard, we like to think of our campus as a really great place to test new ideas, new ways of doing business. It's a great place to do pilot projects. And essentially that's the case because it's a very decentralized organization. Even for a university, it's sort of in a league of its own. It's also very large. We have 650 buildings total, 25 million square feet, 2 major district energy facilities, and we have, 12 schools and so many leading faculty in sustainable research, technology, and design to help us along the way. Part of this is actually to learn from our faculty and students on campus. One of the ways we try to do that is to integrate what we call the living lab. And essentially that is where we use our campus as basically a laboratory, a research space for faculty and students to test their ideas. And we partner with multiple schools on that. And some of that is integrated into this project, the SEC. We also have a major part of this project was the integration of healthier materials. And I'll talk about that a little bit more when I talk about the certification of the project. But overall, Harvard was one of the earliest adopters of LEED certification. We have, I believe it's the most LEED certified projects of any institution in the world. And this project here is LEED Platinum. And also we have gone a bit past that into and looking at other potential certification programs that I'll tell you about. And also just some background about this building in itself. The Harvard is located in the Cambridge and Boston cities in Massachusetts in the northeast of the US. Essentially our main older part of our campus is on the Cambridge side here. Across the river, we have our business school and our athletics area. Now we're essentially expanding into this Alston neighborhood of Boston, and the SEC located right here. And we have a lot more expansion over the next several decades, essentially building up a new hub for research and community. And this is just some renderings of that. Is essentially going to have mixed commercial office space. There's going to be a hotel conference center and residential space as well. So this building, along with the district energy facility, is meant to be the anchor for this new neighborhood that Harvard is building currently. So back to the SEC, Science and Engineering Complex. This is the home of the John Paulson School of Engineering and Applied Sciences. And essentially the school's essentially moving to this new building from its previous neighborhood in on the Cambridge side of the river. The building has, like I said, a lot of cutting edge technology, world firsts, higher level numbers about the building. As far as the ventilation system is concerned, we use MERV 14 filtration along with a MERV 8 pre-filtration system. Total supply is around 190,000 cubic feet of air. And yeah, essentially it's meant to be a positive impact on nature. And one of the nice things, if you're in the building and you're looking out into the neighborhood, these terraced green roofs, it's almost like the green roof will blend into the tree line. So it's almost like you're seeing a very green space when you're in the building looking out. And I'll tell you about this interesting facade as well. But first, a little bit more on the material side. So this was one of the main highlights of the project, because the idea is in the US and in countries around the world, there are thousands of these products, chemicals and things, and only a small fraction of them have actually been tested for impact on human health. And there's a lot of evidence showing that there's certain classes of chemicals like antimicrobials, phthalates, and other substances that are directly impacting human health, and they're put into everyday products that we buy. And with this building, with the SEC, we wanted to really go through as many products as we possibly could. We evaluated over 6,000 products and essentially screened them for these toxic chemicals. And essentially we're sort of making a statement towards the future. So anything from the furniture to the flooring, ceiling, all the way to like the mechanical rooms. Like you might find a technician that's repairing a network cable or working on plumbing, and those items are specially ordered without these chemicals because they're essentially meant to say that we don't want these chemicals to be produced in the world for these reasons, essentially because they're causing so many other problems, especially locally. So that was one of our major undertakings, and it's also part of the longer term life of the project because, you know, essentially this part of that living building challenge that we're looking at doing, or that we did with this project, where essentially it requires you, unlike other certification programs, where you have to really stay with it and continue operating a building in a sustainable way. So like I said, PVC free pipes, sustainable wood products, no formaldehyde, everything is essentially red list free, and so on. So this is a photo from the lab space. I like to talk about, this is actually the area where I worked on mostly for the project. I'm more on the retrofit side, existing buildings person, but I got involved in this project specifically because of the point that Stefan brought up earlier, which is the laboratory ventilation air changes. So at Harvard, we developed over the past 4 or 5 years, myself and along with a team of industrial hygienists and safety experts, and we essentially developed a new risk assessment program that is Harvard first, and we actually utilize a piece of research equipment to do this real-time quantitative inhalation risk assessment. It's actually a sort of an atmospheric science sort of device that it uses spectroscopy, and we can characterize, you know, worst case scenarios and things like that. So it's very different than the on-demand ventilation system, but for us, we like it better because it gives us a lot more, you know, understanding of what's actually happening at the bench, and we get those readings right up close. And I could talk about that project at length. I actually gave a presentation on it last week for the International Institute for Sustainable Laboratories. That's a great organization too, by the way. If you're looking to learn more about these types of topics, I'm very involved, and like I said, I talk about this project quite a bit with I2SL. But essentially, the idea was to make the building very plug and play with exposure control devices. So essentially, every bench has a tap where you can, you know, directly tap into a new exposure control device. So it allows for a lot of flexibility within the research, not limiting the science, but also maintaining those lower air change rates. So another sustainable feature, talking about that living lab idea before, where we're using the campus to do research, it's essentially the entire building was installed with circadian rhythm lighting. The lighting matches the spectrum of light from sunrise to sunset, which and essentially we're studying the impact on that because we think that there's, you know, quite a lot of benefit to that. Another interesting thing is the facade. It has a unique enclosure, essentially, that it's made of a hydroformed tensile steel. It's structural steel, and essentially it was created by a team of engineers and lighting and climate specialists, and they basically created a material, a stainless steel material that allows the building to maximize the solar gain during winter months and reduce it during warmer months. And the idea is that it actually helps shave the peak loads on the building. And it works very well. Every one of the pieces of the facade has its own special shape and design depending on where the sun's coming. There's actually 14 different shapes of the steel, and it essentially, like I said, it really helps keep the building cool, but also insulate the building or allow that daylight harvesting in the wintertime. And this is actually mostly installed in the laboratory buildings, or in the laboratory floors, which are higher up in the building. And you can see it right here at the end of the hallway. This is what it looks like looking out. The building was, like I said, it was installed with the 2050 goal in mind, becoming fossil fuel free. However, we're not quite there yet, so we had to install a natural gas, a very efficient natural gas district energy facility, which is located about a block away. Essentially, it's a produces chilled water and hot water. It has a 1.3 million gallon tank to produce chilled water storage during off-peak times. And this is when energy is cheaper and less polluting. And it also sort of acts like a battery for the building. And it's also partly cogeneration as well. And like I said, this was designed with 2050 in mind. We also looked at the building from a resiliency standpoint for year 2100, sea level rise, storm surge, and that sort of thing. So, you know, part of the reason the piping is higher up off the ground, and there's a lot of other pieces like that. It's meant to brace those worst case scenarios of storm surge, since we are near the ocean here in Boston. And this will essentially allow the SEC building to operate as a community safety place in the event of a major storm. And this facility will also power some of the other buildings that's going to be built in the neighborhood. And then I wanted to mention this too. This is rainwater storage. So the building, the area has a lot of green space around it, and it's all collected into these main tanks here. And this is 75,000 gallons of rainwater is what this holds. And it's actually used for the reverse osmosis deionization water. It's actually produced from the water that we're harvesting on site. So this is a photo that I took from the rooftop. We've since installed solar panels. They were not installed pre-occupancy, but we got them in there right after. We also have a major energy recovery system, Convecta. At the time it was designed, it was the largest in the world, and around 2018, 2019 when it was going in. I think it's been surpassed by now, but essentially this is our major energy recovery system, and also with the reduced air change rates as well. This is just another way to reduce the overall energy used by the building. This is a photo of the internal area. There's a lot of these spaces that are meant to be shared hoteling spaces. So people who travel here to work here for the day or a half a day have lockers where they can store things and rent small rooms to do their work. And there's plenty of places like that. It basically allows for a nice community sort of space that makes it more inviting, because this is supposed to be a building that's really inviting people from the other side of the river to our new campus. And you can see here, like for the rainwater savings, we have all these green roofs. This is an aerial view looking down. There's a parking garage and loading dock underneath. And this is meant to be like a major event space. You could have concerts, commencement, and all the landscaping is local species and things like that. I could talk about it a lot more, but I think I've already went over time, so I think I'll go ahead and end it there.
So thanks a lot, Quentin. A lot of details, a lot of cool pictures. I love the landscape shapes and also the facade shapes, and the possibility to bring light in winter and block lightning in summer, and such really clever things. Really amazing. We have a question in the chat for you. What selection criteria was applied while selecting material of casework and fume hoods?
So the selection criteria for casework and fume hoods, actually, let me see if I have more details on that. The one thing I can essentially say is that the big focus around the materials for my office was on the chemical reduction, the removal of toxic chemicals. Well, that being said, there are, for safety reasons, potentially reasons why, not every single one of those chemicals was removed. Most of the time that they were, we have found a lot of workarounds and found natural chemicals in that work. But yeah, I don't have any other details beyond that around the casework specifically. I know I got to essentially participate in a selection mock-up for design, but I don't have any details on that.
Okay, so everything okay? I look to the time, and I directly hand over to Alexander Bischel. So your impulse, looking forward.
Thank you very much. I will give you an overview about Green Labs, about energy efficiency at Boehringer Ingelheim. And I will give you some topics about how easy it is to save energy. It's not really hard to save energy. but we have to look at the buildings, we have to look deep inside, and we have to look what the users really need inside. And we know what our buildings need energy. And we know, for example, the office buildings have an amount by around about 2.5% of the whole sites of BI. Böhringer Biberach and Böhringer Ingelheim in Ingelheim are sites with a lot of labs and production buildings, and the office buildings do not use really much energy. But let's start. Project cost. Maybe all of us know that operating costs are really much higher than the cost we need to build a building. And this is why it's really, really important to define really a clear structure when we plan and construct a building, because afterwards it's really much more difficult to change anything. When we don't have the flexibility to optimize during operating of a building, it's really, really hard to optimize anything. Now let's have a look at the energy consumption for a standard lab building. A standard lab building maybe for a research lab. We see one for winter time and summertime, and we see that the process equipment and the air conditioning are the most important energy consumptions. Illumination in wintertime, okay, but in summertime, that's not really much. And therefore, we started, I think, 25 years ago to reduce energy consumption, and we started with the equipment and with the air conditioning, because there we saw that we could really reduce a lot. And what did we do? We found out, we structured it in three parts, in three topics. In structural measures, for example, are really flexible buildings, flexible layouts, flexible architecture, and flexible technical systems. Then technical measures. I highlighted the first and the third one because there is really much, the potential is much higher to reduce energy. And the mode of operation. The mode of operation is, it means the parameters, airflow rates, temperature levels and so on, pressure levels and so on. And there we saw the potential is really enormous to reduce and to optimize. Here we see some topics we saw that we could reduce really a lot. And let's start with the air exchange rates. We found out that 1 cubic meter air per hour costs around about 2 euros per year. Therefore, if you have a building with 500,000 or with 1 million cubic meter air exchange per hour, you can save really enormous when you reduce the air exchange rate by around about 5 or 10 or 15 or 20%. Therefore, we focused at the beginning of our optimizations on the air exchange rates and on the quality of the air. For example, humidification in wintertime, we saw that we need a lot of steam to have a really good air inside, because the cold air comes inside, and when it's hot, when it's normal temperature, room temperature, it's really dry, and then you need to steam, for example, to have a good air inside. And only this humidification, we calculated it. We made a calculation about saving potential, and we saw that in the side of Biberach, on the side of Biberach, we could save by around about 1.5 million, between 2 million euros per year, only to reduce the humidification in wintertime. And we reduced it in a way that we set the level to 0% night, Saturday and Sundays off work time. And in working time, we reduced the level from 50% to around about 40% humidification rate. And what we also see that we needed to look at the buildings inside, and to check the temperature levels, to check the airflow rates and so on. And we saw that in a lot of rooms, we did not need the parameters that was defined. Therefore, we could reduce a lot, maybe in labs or in some rooms that are really not needed for normal laboratory areas. We could reduce enormous airflow rates, maybe storage areas for something, paper or so on. You don't need a lot of air exchange rate in such rooms. Then another topic is dynamic air pressure. When you have a flexible air exchange rate, maybe daytime and night when the people are off work, we have a lot reduction of air exchange rate. And therefore, it's really important to reduce the ventilation. If you do not reduce ventilation, the pressure in the ducts are really too high. And you need enormous, much more electrical energy. And you destroy a lot of energy. What we also heard, that a heat and the cold recovery system is really important to recover the energy that otherwise goes out to the atmosphere. It's lost when you don't have a heat and cold recovery system. And for everything, it's really important to have a flexible automation concept with maybe with a data server. If you don't have any data about parameters, about temperature levels, about pressure and so on, you will not be. It's not possible to optimize anything without data. When you don't know what the technical systems do, what you have inside your rooms and your areas, there's no possibility to optimize anything. Now let's have a look at our test building. It was built between 2003 and 2005. It's a lab building, really a bigger lab building with special labs inside, and we planned it and we constructed it. And it was really a energy efficient, a really high energy efficient lab building. This was our test building. It was built in between 2003 and 2005. And it was a high energy efficiency building when we built it. But we used it as a test for an enormous reduction of energy. And we tested, for example, the humidification, reduction of humidification, air frequency rates, and so on. And we see that between 2006 and 2012, we reduced the energy consumption in this building by around about 50%. And what we did was only changing in parameters. We had a look in each room and checked what is really needed. When the people are off work, they don't need any temperature by around about 22 degrees. They don't need any air frequency rate when there are no drugs inside or no substances inside. And then we did really hard breaks and reduced whatever we could reduce. And the result was we reduced the energy consumption by around about 350,000 euros a year. The price basis was 2014. But we only needed around about 60,000 euros only for changing of software and parameters. It was not really much to put inside. We did not need much money and we could save a lot of money. And when we saw the result, we transferred this results to the whole site of Biberach and to the site of Ingelheim. And here you see the result for the whole site. And you see here a figure, it begins in 2003 up to 2021. The site was increasing by around about 52% floor space. And the energy purchase, and this is the energy that comes in the site that we buy from outside. It's electrical energy and a little bit of fuel. It's not a calculation. It's a hard purchase in kilowatt hours. And you see that we reduced the energy consumption for the whole site by around about 8%. The energy consumption of 1 square meter floor space was reduced by around about 40% for the whole site. And this is really enormous. And here, the last slide, here is the site of Biberach where we did this. A lot of production and lab buildings. Where the site, we have around about 7,000 employees there. And we have a lot of production and lab buildings, not really many office buildings. And therefore, we could reduce really such an enormous amount of energy. Thank you very much. And please ask me what you want.
Thanks a lot, Alexander, and thanks a lot for the insights of some numbers of euros and so on. I think this is really cool to see and to know what you did there in Biberach. And my question would be to you, how did you find the potential of these optimizations? Did they fall from the sky, or what did you do?
No, the normal thing is to look for contractors, and they sell you everything. To change maybe heat recovery systems and to change machines and so on, to change equipment. But this is really too expensive. And what we did is you need to know what happens inside the buildings. And then when you know what happens inside the buildings, you see what you have to do to reduce the energy consumption. It's not really hard. It's easy, but you have to know what's going on inside.
So you from facility side, you have to speak with the lab users to look to the process. What are you doing? Is it dangerous or not? Can we reduce?
Exactly.
When do you work, and so on?
Exactly. And one example, we started, I think, 25 years ago with an analysis what the people inside the labs really do the whole day. And we see around about 50% of the time they do not need the lab conditions. And there, 25 years ago, we decided to put a switch near the door, and they had to put the switch to have the high level air frequency rate. The normal state was, until now, it's a low level air frequency rate, and only when they handle with drugs or some substances, they have to put on the switch, and then the airflow is going up. And
yeah,
only this.
It sounds very easy.
It is easy. It's really easy. You have to look at what's happening inside and how the people work, and then you find the results, the solution. It's really easy.
Yeah, it's like I think it's like at home. You go to the kitchen. I want to cook something, fish, for example.
Exactly.
Now I have to speed up a little bit
Exactly.
the conditioning and so on. And if you go out, you switch off.
Exactly. Or maybe another example, when you look at your behavior, maybe on Sunday, is it necessary to drive by car 100 kilometers to drink a cup of coffee? Maybe this is one possibility to reduce.
You can visit our Labcafé and drink a coffee here, and
yes,
and look to the impulses online.
Yes.
Great, Alexander. I would bring Steffen back to the table.
Yes.
And a question to you, Steffen. You showed a great project with wood construction. What were the biggest challenges in realizing such a research building made of wood? I think about fire protection, of course, acoustic, but also vibrations, because lab equipment is sensitive. And can you say something about that?
The biggest challenge was in the beginning. I showed you the picture of the building in the forest. The campus in Jülich is really cut it out of a nice forest, and all the trees which are still there are forest trees. So my first approach when I was on the site was you have to build in wood. You have to build out of the wood which is cut it out of the forest. So, and this was actually my first. So the second thing was because the total area of the project was very small. And we already knew that probably only 2 floors would be the solution. Then I said, okay, the location, and if it's only 2 floors, probably it's possible to go further in this idea because we have less fire protection rules. and we started with the project 2017, so 5 years ago. But then the biggest challenge was that the client said, "You are crazy. You're completely crazy. Why discussing a lab building in wood?" So they completely destroyed this idea in the preliminary design. And then we had the thing that the director of the Institute of Energy and Climate, so as I said, he said, if we do not reach silver or gold with the Institute of Energy and Climate, I will search for another place. So we had to find topic to reduce the carbon in the project, even because of the quality of the campus infrastructure is very bad, and it's supposed to be changed in 10 or 20 years. So the only thing to furtherly reduce carbon was the carbon footprint of the construction. And then suddenly they said, you were talking about wood. This is still an idea we can follow. And then we suddenly were in. And then the biggest hurdle was already done. But then there are a lot of details you have to face, but this is another 1 hour lecture to talk
so
about.
We will make a follow-up. Yeah, okay. Thanks a lot, Steffen. I think it's a challenge to realize a lab building only with wood construction, but really cool that you did that. And Quentin, you back to the table. A question. So certification can be a target to bring such crazy idea to the tables. And looking to certifications, you said the SEC project is both LEED Platinum certified and Living Building Challenge certified. And is Harvard pursuing both certification on projects moving forward, or are you changing your certification pathway?
That's a great question. I actually didn't get a chance to speak about the Living Building Challenge much, and I wanted to say, Steffen, that when I saw the project, it reminded me a bit of the presentation I saw on University of Nottingham, the chemistry building. They had a very much wood type of architecture, if you haven't seen that. But yeah, so historically, since going back to 2009 and even earlier, it's about 2009, Harvard created a sustainable building standards, and the idea was to the higher tier of project, the more millions of dollars we spend, the more sustainable the building should be. And in the case of something like the SEC, that was we want to go LEED Platinum, and that's been our main target is LEED certification. With the SEC, we decided to pursue that, and we achieved LEED Platinum, but we also decided to approach the Living Building Challenge, International Future Living Institute. It's a bit of a different type of pathway. It's more challenging in some ways, and the idea is that it's not quite as prescriptive as LEED, but you have to show in a lot of categories that you're going really far, you're really pushing the envelope. But there's also this major component which I like personally, which is the idea that the certification stays with the building throughout its life. So you have to continue operating the building as you intended, and there's a lot of criteria around that. And I think like I said, Harvard is a great place to pilot, try new things. Right now we're trying Living Building Challenge as well. There's another project that we're working on there, and I think we're really just trying to understand which pathway is better for us, or do we want both, right? Because they both have their really strong benefits. But with the Living Building Challenge, there's a lot more depth on the materials component, which was a big part of the project. There's a Living Building Challenge has these pedals. There's a materials pedal, equity pedal, beauty pedal, and others. Those were some of the ideas we wanted to try out with the new SEC. But yeah, it'll be interesting to see what we do in the future for sure.
Yeah, we will look to you. And another question to you, Quentin. Can you recap on what were the top 3 sustainable design innovations for the SEC project?
Yeah, definitely. And this is biased somewhat. We have to look at the the facade, the interesting daylight harvesting and things like that. It's the first of its kind, especially it was so custom. So we're actually studying that to see how it works. We call it the cheese grater because it kind of looks like what if you were to it has like a grater type of effect. But it like I said, we haven't had any problems with it at all. And like I said, it's been working really well. I think another thing is the materials piece, really that I've talked I think at length about, which is the healthier materials component. And then I like the ventilation design, and it's sort of it was designed with a new management plan in mind. We have a lot of flexibility to adapt to the research needs at the time. And we're, moving the building down to, 4, or keeping the building at 4 air changes occupied, 2 air changes unoccupied in the lab spaces, which is pushing the envelope, as far as the standards are that we follow. And while also we want to maintain the healthiest buildings we can. So that's also a learning process too. We're working with we're partnering with the scientists, the students, and the building staff, and it takes everybody to make something like that work. So we're really proud of it.
Great, Quentin. Thanks a lot for your insights to the SEC project. And the last question goes to Alexander. And Alexander, you talked about reducing air consumption and so on, and you talked much about flexibility, also for the technical system. And yeah, what is flexible building for you, and what advantages do flexible buildings have for you?
A flexible building is a building that allows changings inside, changings of layouts without really spending enormous money inside, and changing of automation, of programming and so on. This is a flexible building that allows us later to adapt for the users what they need. This is really important, and we have to spend a little bit more money when we plan and build a building, and we reduce afterwards enormous. This is important. The flexibility needs a little bit, not much money. It's not much, 1 or 2% of a project cost, and afterwards we save 20, 30, 40% during a lifetime of a building.
Yeah, and I think the phase 0, starting before the project is starting, thinking about the concept in general.
Exactly.
To think what steps could be in the next 10, 20, 30 years, because everything is changing. The lab processes are changing, the products you produce are changing, everything is transformation and so on. And yeah, the lab building have also changed. And today everything is lab, tomorrow it's perhaps also lab production and more office instead of lab, because now many things are automated, for example. So I think investing a little bit more time in the very early stage, a good concept, saves you much money during the lifetime. Yeah, so thanks a lot to Steffen, Quentin, and Alexander for your great impulses and insights. To the audience, thanks a lot also for your time. If you want to forward this session to friends, we have recorded this session. So in 1 week or 2 weeks, it's on our website, the video, and also on our YouTube channel. If you missed another live event about Green Lab certifications, for example, or well-being labs or digital labs or other topics, it's on our website. You can look to that, of course. And if you want to start your own Green Lab project, a new one, you can contact, of course, Steffen Vogt from Wolf Architects. He's an expert in green buildings. We saw that. And perhaps if you want to optimize your lab operations in your existing lab, so I have the t-shirt here. We have a green basic program as Waldner. So we come on site, we make an inspection, so a technical inspection, and also a workshop together with the lab users. We look to the process, then we prepare ideas and action, and in a follow-up workshop, we discuss these ideas and prioritize that, and then we directly can bring it to practice. So we can support you with our Green Basics program. So you see that also on our website. And if you want to know more about Green Labs, we have the next Labcafé on the 7th of June. The title is Green Lab Benchmarking, Optimize Your Building Operations. And I'm really proud because the Bauakademie from Germany will show the first white paper. And on this white paper, many big companies, also Boehringer Ingelheim, Covestro, and BASF, and other companies worked on this white paper, and they will show that to public in this session. So please sign up and join the next meeting on the 7th of June. So thanks a lot for joining. It was a pleasure, and have a nice evening here in Europe and a nice morning in the US. And thanks to the 3 speakers. Thanks a lot. Bye.
Bye.
Bye.